All right. We're going to get going. We have a lot more people who RSVP'd, but that's all right. It is the summer, so hopefully we do get some more attendees, but we are recording this webinar. So if folks do miss it, they'll have the chance to watch the recording and see our slides, which will be posted on our website shortly after the webinar. Just as a quick overview, this is our 7th webinar in our NISBIP webinar series. We started off focusing on the specifics of how to apply to our incentive program for buses and for chargers. We talked about fleet electrification planning in depth and stacking most recently. How our New York School Bus Incentive Program can work with other federal, state, and local or utility-run funding opportunities, and those are all posted to our website, our NISBIP program page. So if you want to go back and look at any of those, they are available, both the recordings and the slides. So today we'll be talking about site planning for electric school bus charging. Our topics today will include a brief overview of the fleet electrification plan and what sort of components tie into site planning. What sort of inputs are really important in terms of getting into the site planning process. Things around how you're going to engage with the utility and what things the utility will be looking at both on your site and the grid around your site. Importantly, we'll look at the spacing requirements for equipment, all the different types of equipment that you will potentially need on site: transformers, switchgear, new panel boards, the chargers themselves, and the dispensers. So we'll get into that distinction and what that means in terms of space. And then other types of facility upgrades that might be required depending on the age and layout of your facility and the age, the type of equipment that you have in place. We'll then get into sort of how we phase these projects. So trying to make best use of the time and funds available for capital projects, and trying to ensure that we don't have to dig up the ground as much as possible. And then a little bit more in terms of next steps with once you get past the planning stages, getting into actual implementation. I should say, I should have said this already, but this webinar is primarily going to be presented by John Havrilla from Wendell. John is the Director of Alternative Fuels at Wendell. He and Wendell have been a partner of ours from the beginning, and they've been going through both the planning side of these projects and into implementation with some school districts now. They have lots of experience looking at things that I just discussed, and also have previous experience on the transit electrification side. So really excited to present and turn it over to John Havrilla, and I'll be on as well, answering some questions. And I should note that on the questions, Q&A will be open in terms of the chat. You will not be able to ask a question verbally, but if you ask your questions in the Q&A prompts, we will respond to them there. And then any larger questions that we think are worth discussion at the end, we will have some time for that as well. So now over to John.
Thank you, Vinny. I appreciate it. Sorry. So first thing we want to do is go into the fleet electrification plan. And as Vinny indicated, this topic's been covered a lot. So what I'm really going to try to focus on are key areas that impact the site planning. And I would like to emphasize that having a good fleet electrification plan is critical to site planning and making sure that you don't have to redo something you've done because it wasn't considered early on. And again, typical fleet electrification plan consists of several tasks. Obviously, these can be modified, but these are pretty much the standard tasks. Data collection, which is critical to all of it and is probably the heaviest lift for the school districts. It's really identifying all the information that we need to do our job. The second task is route analysis. In the route analysis, we're really determining what the minimum battery size is for the buses that are running the routes. And that feeds into our conceptual charging strategy where we look at how much time the bus is actually parked on the lot. I mean, obviously overnight charging is critical, but also there's potential need for charging between the AM and PM routes. We need to understand how long the bus is going to be there, how much energy the bus has consumed in the morning route, and how much is needed in the afternoon route, so that we can determine how we need to charge those buses to replenish that energy such that they have enough energy to complete the afternoon routes. So that develops the charging strategy. It also determines the size of the chargers. So, there's a lot of conversation between level 2 versus level 3 charger. What we're finding is that level 3 chargers for a lot of districts are critical, and that level 2 chargers may not be adequate. And a good route analysis and charging strategy will tell you that. The charging strategy then determines what the load profile of the bus charging for the entire district would be. That we then feed into our conversations with the utility so that they understand what the peak demand is, how it grows over time, and what the school district is going to need from the utility from the standpoint of power to charge the buses. Once all that is identified, then we can develop the phasing plan. And the phasing plan really looks at bus procurement schedules, how you typically would purchase buses, the utility, what upgrades they may need to make, and then design and implementation of charging strategies. Not all of this has to be done at once. We have till 2035 to meet the mandate. So we want to understand how we can phase this in gradually and basically eat the elephant one bite at a time. And along with that, our phasing plan estimates, getting an estimate, a good solid estimate as to what it will cost at each phase to get the transition to battery electric buses implemented. The main goals of the plan are to provide a path towards zero emission fleet by 2035. In essence, it's a roadmap. As things change, as bigger batteries become available, different technologies become available, the plan should be a roadmap to help you make decisions as you move forward. It'll provide information to the district in order to make informed decisions regarding design and implementation, and will allow you to evaluate and recommend infrastructure upgrades to your existing facilities. The ultimate goal really is to assist in conversion to carbon-free fuels. So let's talk a little bit about site plan inputs. Bus fleet information, obviously, is one of the most critical elements. Fleet size, how many buses are we dealing with? What's the replacement schedule so that we can look at how that happens over time? And what types and sizes of buses do you have? Type A buses, the smaller buses, type C, type D, all have different capabilities, and we need to understand, what the mix of fleet is. Bus schedules and route data. Detailed bus routes are critical to determining, what the minimum battery size is that will be required to make those routes. Obviously, one of the issues that we spend a lot of time on is sports activities, band, other activities that are after school. Those runs become important as well, and we need to understand what those are. Bus parking and storage arrangements. How are these buses going to be charged, and where are they going to be charged? So are they indoor parking, outdoor parking? We have a mix of both across the state. What is the location? Is it just at one site? Is it multiple sites? We also look at fueling, current operational requirements for fueling. The fueling helps us do back checks on our battery size calculations, because we can look at how much diesel is consumed and make sure that we're correctly looking at how much electrical energy is going to be required to complete the routes. Utility data, the name of the local utility, existing service size and location, and the utility contract. It's critical to bring the utility into the conversation as soon as possible. We have started now at the very kickoff of these planning studies to bring the utility in. The utility can be a very strong partner in developing these programs. Existing electrical distribution information. How much power do you have on site today? What is your switchgear and distribution of electrical power throughout the facility today? What does that look like? Because we want to understand how many buses can we charge today without doing anything as far as upgrades to the main service or to a new service. And so those pieces are critical. And then I'm going to talk a little bit about fire protection. As you are probably all aware, battery electric fires have been in the press a lot. The information that we've seen, though, says that battery electric bus fires do not occur with any greater frequency than diesel or gasoline bus fires. And that's across the spectrum, including transit. However, when a battery electric bus fire does occur, they are lithium-ion battery buses for the most part, and they burn hotter and they create their own oxygen as they burn. So it's a little bit more difficult, in fact, a lot more difficult to put out. So we recommend a fire protection scheme for those buses if they're indoors, so in maintenance facilities or if they're stored indoors. And then the existing site plan. The existing site plan is important because that's the piece that we're building off of. Some utility considerations. So charging battery electric buses will require additional power from the utility and will require utility upgrades. In a lot of cases, in fact, most cases, we need a second service from the utility to charge all of the buses once you reach 100%. The level of charging may impact service levels. Large fleets may require medium voltage service from the utility. And I can give you a little bit of an example of that. So for a standard service, what you have is the utility has the line coming in, feeds a transformer, feeds a meter, and that is the utility side. From the meter on in is the customer side. When you look at medium voltage service, there's a limit as to how big a transformer and how many transformers the utility will put on site. If you have a very large fleet, and we have encountered this, the utility will say that you need to take power at a medium voltage level. This is usually 13,800 volts or somewhere in that range, depending upon what the distribution voltage of the utility is. What that does is it shifts the ownership of the transformer onto the client, and you may wind up with multiple transformers on your site. The meter does move as well, but the key point here is that you're now taking power at a high voltage, 13,800, as opposed to 480 volt, which is traditional. The next question is, can the local utility supply the required power for the project? Large demand may require significant utility upgrades and keep increasing or impacting costs and schedule. The answer to this question is yes. The utility can supply the power. The question becomes at what cost and how much time does it take? So it's very important that we work with the utility to understand what that timeline is and what that cost is. So what are the costs the district will incur to upgrade the utility infrastructure to serve the facility? In New York State, as in most states, utility upgrades are chargeable to the customer that require the upgrades. Now, with the utility make-ready programs, which were required by the New York State Public Service Commission of all public utilities, up to 90% of these costs may be covered by make-ready programs. Again, a good point to make sure that we're talking with the utility up front, making sure that we get the client in line to be able to take advantage of those make-ready programs as they move on towards implementation. The last bullet point here is some charges may be able to be put into the utility's rate base if the upgrades benefit multiple utility customers. So if they have to do an upgrade to a substation, but it'll benefit other customers outside of just the school district, some of those costs can be put into the utility's rate base and not charged to the client. So equipment locations. First, I'm going to talk a bit about the main service feeds and the big power equipment. The first piece is the new pad mounted transformer. I indicated earlier that in a lot of cases, in fact, most cases, a new service will be required. The utility will come in and set a new pad-mounted transformer, and this size can vary anywhere from 750 kVA to 2500 kVA, very large transformers. It depends on how many buses you have and the rate at which we're charging. But that'll be utility owned and provided. Service entrance switchboard is this little piece here, and I've got pictures of all of these, and we'll go through what they look like and what they do. But it is really, think of it as your main circuit panel in your house. The power comes from the utility into that panel. That switchboard panel will have metering in it. It will have protective relaying in it, and then it will have distribution breakers out of it that will then feed the charging switchboards, which this one's not really clear, but this little 3-block cluster up here is a charging switchboard. So this feeds power to these, which then feed power to all of the chargers. Then there is a fire pump, which typically goes into a new fire pump house, unless there is a room within the building, which we have been able to do, include the fire pump inside an existing building. And an emergency generator, which is code required for the fire pump. So this emergency generator does not feed the chargers. It does feed the fire pump. So here's some of the equipment. So here is the pad-mounted utility transformer. Again, utility owned usually, unless you're taking it at medium voltage service, at which point you would own this transformer. And they're fairly good size, 75 inches by 73 by 73, and about 9,800 pounds. This is a 1500 kVA transformer. So this is about the middle of the road. The service entrance switchboard gets fed from the transformer, and it typically will have a metering compartment, a main breaker, and then distribution breakers, which will then feed charging switchboards, which are located near the chargers. And you can see the sizes of these as well. The switchboard here, the middle one, is fairly large. This is a 3-section switchboard, 10 feet by 30 inches by 90 inches, about 3,600 pounds. It will depend upon how many chargers, how many buses you have. That'll determine how many chargers, that'll determine how many switchboards, and then how big the service entrance needs to be. This kind of depicts what a fire pump house would look like. These are prefabricated buildings, a bunch of different styles to make them blend in. But in essence, this will hold the fire pump, which is depicted here, and all the controls for the fire pump. This one here is an electric driven fire pump and does require a diesel generator to back it up. So this is an installation, and you can see the building in the back here. That is actually the fire pump house in this particular site. The Kohler beige box here, that is the backup diesel generator for the fire pump. The dark green box in the front here is the transformer. So you can see it's a pretty good sized piece of equipment, and there's a side view of it here. And then the switchboard, the main switchboard is behind it. And unfortunately, you're looking at the back end of it here. But the power feeds from the transformer into this switchboard. Then from there, it goes into the smaller switchboards here, which feed the chargers. So these are 60 kW, or these are 150 kW chargers in this particular site. Another arrangement that we've seen is you have the transformer here, the main switchboard here, the charger switchboard here, feeding a bunch of chargers. These are 60 kW chargers. And these chargers have remote dispensers. So this is the dispenser. This is the piece that you see the cable here. This is the piece that would get plugged into the bus. This dispenser is fed from one charger. So each charger in this scenario would have one dispenser associated with it. So one of the issues that we're faced with when we're working with school districts is, where do we place all this new equipment? It's not so difficult with more rural or even suburban school districts. But when you get into city school districts, and in particular, we've had a lot of issues on Long Island, space is very constrained. Where do you put this equipment? So that becomes a challenge that we start looking at very early on in the process. So again, here's a charger. And as you can see, these are the dispensers here. These are Allen Bradley dispensers. And so you see a row of chargers and then a row of dispensers. These dispensers the cable on the dispenser can be up to 27 feet, so they have to be relatively close to the vehicle that they're charging. There are different types and sizes of chargers. The smallest that we've been using is a level 3 24 kW charger, and one of the models is a ABB TerraBox wall box. There's many different manufacturers, and they can come in several different configurations. So you can have one port that'll charge one bus. You can have it have 2 ports so that it can be connected to 2 buses. And you can also have it pedestal mounted or wall mounted. And these are about 30 inches high by 23 inches wide by a little over 11.5 inches deep. Another option that we're using a lot is the level 3 charger. This is one manufacturer. It's Camber. They can do, in the same size footprint, can do a 60, 120, or 180 kW charger. And the size of these are roughly almost 80 inches by 40 by 31 inches. And the cabling here is integral to the charger. But again, there's a bunch of different types and styles. We can do remote dispensers as well as dispensers connected to the charger. Some additional facility upgrades. Ventilation has been a key. A minimum amount is required to meet code. So code requires a certain amount of ventilation in bus maintenance facilities and bus storage facilities. Increased ventilation may be necessary if we're charging indoors. So if the bus is parked indoors and we're charging indoors, the chargers give off heat. That extra heat needs to be removed. If we use a charger with a remote dispenser, in a lot of cases, we can put the charger outdoors and the dispenser indoors. That alleviates some of that problem. But ventilation is the thing that we need to consider as well. I talked a little bit about fire protection. Enhanced fire protection is strongly recommended to suppress flames and protect the structure from lithium-ion battery fires. Lifting equipment. Battery electric vehicles are significantly heavier than their fossil fuel counterparts. We routinely go through and check bus lifts to make sure that they are adequate to lift the battery electric buses that we're recommending for your district. We've found some that are not adequate. In most cases, the newer lifts are adequate and nothing needs to be done there. But we don't want any surprises when you get a new bus and find out that you can't lift it with your existing lifts. Structural. There may be requirements to enhance the building structure. If we're charging indoors and we're putting fire protection in, we may need to handle dispensers, cables, conduits that are running through the ceiling to feed these buses. Most bus garages and maintenance facilities in the Northeast were designed to handle snow loads only. We're now looking at putting on solar panels. We're looking at all the electrification. In most cases, we need to look at the structural elements to make sure that the building can handle what we're adding to it. And then we also discuss with the school districts O&M standards and operating procedures. So modifications to existing standard operating procedures to handle battery electric buses, including fire prevention and safety measures, is important. For example, if a bus is damaged on the road, historically, you may pull that bus into the garage for the mechanics to look at it the next day. We would recommend, if it's a battery electric bus, that it be parked somewhere safe outside the building until the battery can be determined to be safe before it is moved into the building. So it's things like that. And also how you're parking the buses and charging the buses. You don't want to get into a situation where a bus behind another bus is fully charged, but the bus in front of it isn't. So you need to look at how we're charging the buses and how they're parked and how they're used to make sure that we're not impacting operations. Talk a little bit about phasing plans. The goal is to develop a phasing plan that achieves these following major goals. Mirrors bus procurement plan. Develop a plan that grows with the fleet. Again, you do not need to do everything at once. There are certain pieces that will need to be done early on, but you don't have to install everything in one shot. And in fact, we would recommend it against that because there's enhancements to bus battery technology, there's enhancements to charger technology that are coming out every year. So as you get into this, it's a good thing to phase it and plan it. Meets funding objectives. Provides an estimate that can be used to develop a funding plan as well as for local and state approvals. Builds on previous steps. And this is important. We've seen this before. People that have gone out and wanted to do pilot programs and have started the plan for 100% electrification but didn't have a plan. We've had to do rework. And if you build on the previous steps and have a plan, it doesn't require rework or replacement of equipment purchased and installed in previous phases. Having a plan and engaging stakeholders, utility, state education departments, school boards early will minimize costly issues moving forward and will future-proof the transition to battery electric buses. This will also minimize site and operational disruption. You don't want to tear up a parking lot too many times. You want to try to plan how you're going to do this and avoid unnecessary in-ground work. And the last piece, really understanding that the design and construction takes time. And I'm going to go over a timeline with you. But developing a plan early in the process is critical to meeting goals. If you keep putting it off, you're going to see that design, construction, and shipping of equipment can put you into a situation where you won't meet your goals. I'm going to go through a site plan here. This was developed for Sweet Home Central School District. Now, this was done back in 2023. This was one of our first school district clients. The first piece here is, this is all phase one. So everything on this page is phase one. The first piece really is looking at the new transformer to be set by the utility. We have an existing service feed. The existing service feed is going to feed a new fire pump and the emergency generator, which is going to feed the fire protection system. The new feed is going to then provide power to this whole back area. This is a new equipment yard, which will hold the entrance switchboard and then a bunch of charging switchboards and some chargers. So these are some chargers back here. In phase two, so phase one took care of charging all of these buses along this back row. So each of these little squares is a charger, and then we also have some charging switchboards located throughout the property. This would get Sweet Home to 34, the ability to do 34 buses in the first phase. You can see the DPCH2. That's a charging switchboard, and another one here. Phase two, we're picking up this group here, which is 2 new charging switchboards, a bunch of chargers, and then dispensers all along the back to charge all of these buses. Phase three, we're adding additional chargers back into the back corner and dispensers out here next to the building to pick up this row of buses here. So we added more chargers here and picking up dispensers by these. That gets them up to 62 buses. And then the last phase, or phase 4, these are the larger chargers, and these are the larger bus battery sizes. We push the larger bus battery sizes towards the end because the bus manufacturer that Sweet Home prefers, which is Thomas Built, does not manufacture a bus with a large enough battery to complete some of their longer routes. The buses that can do that today are the IC buses with a larger battery. If we defer this to the latter part of the phasing, then by that time, there's a good chance that Thomas Built will have a bigger bus, and if they want to stay with Thomas Built, they can. So we typically put some of the larger routes towards the end. And that's part of the things we take into consideration when we do phasing. And we do this working with every school district. We don't develop these in a vacuum and then present them. We work with your folks to tell you, what's the best way to do it, what's the operational impacts, and get feedback. And you can see another charging switchboard here feeding these chargers here. And this would take them up to their full fleet of 67 buses. So let's talk a little bit about design and construction and schedule items. Detailed design. So once you have your plan done, you still need to do detailed engineering. That detailed design can take 4 to 6 months, depending upon the size of the fleet and the amount of equipment and the complexity of the design. SED approvals, standard SED approvals is 6 to 7 months. Now, SED has been willing and has expedited these, and we're actually doing construction, going to start construction on Sweet Home for 3 buses that they got through a grant program. They're able to do that in 4 weeks. So it can be expedited, but it'll depend on what else being done. But again, it's the importance of getting SED involved early on to understand what they can expedite, what they can, and what they will fund. The equipment lead times.
Hey, John,
Yes.
sorry to cut in. Your sound is a little bit muffled. Would you try muting and unmuting?
Sure. Let me get a second. Is that any better?
No. We hear you clearly. It's not. I don't think it's an internet connection issue. I don't know if maybe you can try rejoining the webinar.
Let me try calling in, see if that makes a difference.
Okay. Apologies, everyone. Bear with us.
Is that any better?
Much better. That's great.
Okay, thank you.
Yep.
So equipment lead times, 16 to 20 months. It really depends on the piece of equipment, but the biggest is the switchboard. That's the piece that gets the power from the transformer. Those are taking 20 months, 16 to 20 months. So if you think about it, that's almost 2 years of delivery. So when you start looking at, detailed design, SED approvals, switchgear delivery, that can stack up to a significant time before you start actually being able to charge buses. Utility schedule depends on the extent of the utility upgrades necessary to bring the power to site. If they're putting in a new service, adding a new service and putting in a new transformer, but the distribution circuits are okay, have the capacity, it's typically not very long to do that. If they have to go back and start modifying the distribution circuits, and in worst case, changing the substation that feeds it, those delays can, or those schedules can increase the delivery significantly. So again, it's important to get the utility involved up front so that we can understand what their ability to provide the power is. And again, they can provide it. It's just a matter of what do they need to do to get there. Construction, 12 to 18 months. And, I put a note in here, maybe longer in Western New York due to the new Bill Stadium. The new Bill Stadium is really sucking contractors into that project. It's hard to get electricians, plumbers, you name it. So we have to be aware of what's going on around the school district because we're all competing for the same resources. And I would add that schedules vary with the size and complexity of the project, number of buses, number of sites involved, and funding approvals are not included in these estimates other than SED approvals. So, I think one of the points to this is develop a plan, figure out what all the key milestones are, and look at what it's going to take to implement. And the sooner you start that, the better. Designing construction costs. I can't give you an estimate today of to what these costs will be because it's very site dependent, school dependent, utility dependent. And, but what I can tell you is the utility upgrades will usually require a new service entrance, transformer, potential system upgrades, but that up to 90% of that can be covered by utility make-ready programs. So the utility side upgrades, there is a funding source for that. Buses, obviously that's one of the larger costs. Battery electric buses are more expensive than their diesel counterparts today. I fully expect those costs to come down over time. The electric bus is much simpler, has fewer parts. The biggest part right now is obviously the battery. But NSBIP and the EPA Clean School Bus Grants programs can offset a significant portion of the cost differential between a diesel bus and an electric bus. Charging infrastructure, on-site distribution upgrades, switchboards, charging switchboards, cabling, chargers, dispensers. NSBIP and EPA Clean School Bus Grants can offer a significant portion of that cost as well. But you can't do that without the bus. So they kind of tie that to the bus. So you buy a bus, you can buy charging and infrastructure costs with that. Facility upgrades, bus lifts, potential HVAC upgrades, etc. All of that is SED aid eligible. Fire protection systems, initially when we were talking with SED, they were not aid eligible. They have since changed that position and are now saying that fire protection systems, including the fire pump house, fire pumps, emergency generator, plumbing and piping, is SED aid eligible. So there is financial assistance out there for various programs, and we're seeing more and more programs occurring. For example, the utilities are now looking at not only potentially providing make-ready funds for the utility side upgrades, but they're also looking at programs to assist with some of the major electrical distribution components on the customer side of the meter. So we are constantly looking at how this is evolving and letting our clients know what is the latest that's available. Design and construction delivery methods. There's several different ways school districts can go from planning to implementation. Implementation planning, a lot of school districts are doing pilots. We're doing a 3-bus pilot for Sweet Home. We're doing that without upgrading utility service, and that's why it's also important to understand how much the existing service can feed. Funding sources, looking at what those are, approvals that you may need, and then designing construction, detailed design, what those schedules are, SED approvals, permitting, bid package prep, bid reviews, construction management. Traditionally, schools have purchased through the traditional design bid build, where the school district contracts for all services directly and manages those processes. Usually this is the longest duration because you're stacking everything one right after the other. We're looking at ways and we're seeing how we can actually do design build, where the school district contracts with a designer for, say, up to 30% design, then contracts with a design builder who will finalize the design and construct the project. The design builder manages the majority of the project. Usually it's a shorter duration for overall construction. We're also looking at some additional ways to do it, including tips. Some of the school districts are familiar with tips. That is a purchasing system. You can now buy purchase construction services through tips. We are a tips contractor, and so there's ways that we can do that. There's a lot of different ways this can be done, and speak to your engineer as to what they can do. With that, that concludes the formal presentation, and I'll turn it back over to Vinny, and we can answer any questions.
Thanks, John. That was really great. I know it was a lot of detail and very much in the weeds, but I think that's where some districts are getting to at this point, and understanding all these different inputs and influencers on timeline are really important. So thank you for doing that. We did have a couple of questions come through the chat that I'll just reiterate the answers to, and then I do have a couple of questions that you and I can talk about, unless further questions do come in. But the first question was just around the Make Ready programs that John mentioned that the utilities provide, and if bus companies who work with districts can also access those funds. The answer to that is yes. The Make Ready programs are intended to support vehicle electrification broadly, including all medium and heavy duty vehicles, so not just school buses. And that means, private fleet owners are also able to access those funds too. And then the other question that came in through the chat, aside for a little cheer for the Bills, was, question about the funding side that NYSERDA provides, our New York School Bus Incentive Program, and if we can, I'll come on video too. If we can extend the timelines if there are delays on the utility side or on product delivery side, and yes. Absolutely, we've sort of factored that into our program design, so there is the ability to extend the voucher redemption timeline. If you're experiencing delays, you just need to let us know and provide some documentation on that, and we can provide an extension. Provided my contact information, as well as Hannah Abdu, who is the project manager in charge of the New York School Bus Incentive Program. And then also our Voucher Help Center, who answers lots of questions like these as well, and that's nisbip@energycenter.org.
What I would add to that, Vinny, is when you're looking at your FEP, your plan, understanding how much capacity you have in your existing service is important, because that can determine how many buses you may be able to do prior to upgrading the utility and putting in all this electrical infrastructure. So yes. In the case of Sweet Home, we can easily handle 3 buses. They get much beyond that, then they're going to have to start implementing phase 1, which is a significant capital project.
Yeah, this is our recommended best practice as well, John, as you know, is try and get districts started using that existing service. Use that to then leverage, because you do need to have a bus you do need to purchase a vehicle through one of the incentive programs to access the Make Ready funds. Once you do that, then you'll be able to work on the scaling up and bringing in that new service to support the rest of your fleet. There was another question there about if there is a requirement from state education or other agencies on fire protection systems. I'll let you answer that, John.
Current code has not kept up with fire protection for battery electric vehicles. It's silent. So in reality, you really don't have to do anything. We are strongly recommending against that. One of our transit clients has had a bus fire, and they are, significant fires. We, have a fire protection scheme of which we can make available to you a white paper on that has been approved by insurance agencies, state fire marshals, and authorities having a jurisdiction across several different states. As an engineering firm, we are recommending that you do it, but by code, it is not required. SED is wrestling with this. They're basically saying they initially didn't want to fund it or make it eligible for SED funding because it wasn't code required. And then they looked at it and said, no, it is the right thing to do, so we will fund it. So it is SED eligible for funding. But to be specific on your question, no, it is not a code requirement at this point in time.
Yep. I'll just sort of add to the question a little bit and sort of expand it is, while as John said, there's no requirement right now, obviously insurance agencies are also looking at risk with new buses and charging and things like that. While they have not, they definitely have not said that they're planning to change what they're going to insure. Having an adequate fire protection system is probably the right move in terms of making sure your insurance doesn't change or changes as little as possible with these buses. So I don't see any other questions. We'll keep an eye on the Q&A, but I did, there's a few things, John, that you mentioned, I guess worth just sort of reiterating. You talked about all the different equipment sizes. I understand that they also have access and buffer requirements in some cases. So just, wanted to note
Yes.
that and make sure that people are aware. The equipment can't just be stacked right next to each other in all cases, and you probably saw that in some of the photos. You do need to have some additional space around them.
That's a very good point. All of this equipment needs front and the switchboards need front and rear access. So minimum 3 feet, more like 5 to 6 feet. And the chargers, depending upon the charger manufacturer, will need ventilation requirements, top, front, and potentially back. These particular ones needed very little in the back, but there is definitely space requirements around this equipment. So that's a good point, Benny.
Yep. And then you also mentioned, I think that it's important to keep reiterating this point that the charger itself and the dispenser can be the same piece, but they can also be separated.
Yes.
There is, there are some maximum lengths that you'd want to stick within in terms of the distance between the dispenser and the charger itself. Could you
Yes.
talk a little bit about that?
Yes, the max distance between the charger or the charger and the dispenser is 400 feet. And the max distance from the dispenser to the bus is about 27 feet. And that is with an extra extension on the cable. Standard is about 20 feet. Also, the bigger the charger, the heavier these cables. So, you have to take into account that somebody's got to pick this cable up and plug it in. They're very flexible, but they are still, when you get up to 180 kW output, it's a fairly substantial cable and it is heavy. So we put in, ways to help the operator plug the bus in to make it easier. But, they can be either connected like this, or the dispenser can be up to almost 400 feet away. As can be seen here, these aren't that far away, but you can distance them.
Yep. And I guess last thing I had, you alluded to space constrained depots and different types of solutions in terms of infrastructure and charging. Could you talk a little bit about those? Obviously, you mentioned different types of mounting, but how to deal with situations where we do have space constraints.
Yes. Obviously, if we can, this picture on the left here is a wall box. It's mounted to the wall. We have a cable management system. Here's a cable management system here as well to manage that cable. But if you're very tightly packed, what we have done is we have seen where clients have wanted to add canopies over the buses and we're putting solar on those canopies, but we're also hanging the dispensers in the canopy itself with reels that have the cables drop down so that you don't have the dispenser in amongst the buses. It's actually above the buses. So we've come up with some various ways to help alleviate space constraints. But at the end of the day, there's still a certain amount of equipment that needs to be placed on the site that we need to find places for. We can put it on roofs, we can put it on canopies, we can do a lot of different things with it. But at the end of the day, there's still a need for this equipment. And when you start looking at 3,600-pound pieces of equipment, it can be fairly significant.
That's right. All right. That's all I had. I really appreciate your help going through all this, John. That was a really great presentation. Folks have been asking, can we get the slides? Will this be posted? The answer is yes. The link is where they'll be posted is in the chat. It does take us a few days to get the webinar recording set up and post this to our website. So just be patient, please. And yes, we will have additional webinars. There was a question about when the next one will be. We will be announcing that shortly. As Hannah said, late August is the likely timeline for that. We will probably be talking in more depth about electricity rates and utility bills when as it relates to charging activity. This is we're starting to move from the planning side into implementation, and we do have a fair amount of districts who are charging buses already, and we want to be clear about what things to look for on your bill, how to read those, what to expect in terms of demand charges, which we'll talk more about. But those are some of the things that we're looking to talk about next. So stay tuned. If you haven't already signed up for our email list, please do so. That's available on our website. And not on this last slide, unfortunately, but I will put that in the chat right now. All right, so that's it for today. Thanks for joining us. Thanks, John, again for presenting.
Thank you.
And we will talk to you all soon. Stay cool.